There we go. After a little bit of problems, here we are now. My name is Götz Vollmann. I'm from Ruhr University in Bochum, and I'm going to present you some results from a recent research project. The overall idea of Beyond the Tunnel Vision was bring your own tunnel. I'm not bringing one tunnel, I'm bringing a couple of tunnels. Almost half of the building stock of the German Deutsche Bahn, the DB Netze, you see that up above in the left corner. And I'm going to show you some results from a recent research project that is still running, and we are still in development. So first of all, some things about the situation that we are facing, then about the geopolymers and how they are, how the recipe is developed. Then I'm going to give you some status about the investigation, and finally some information about further approaches. So as Roland already mentioned in his opening words, we are facing a situation in Germany, but not only in Germany, also in all over Europe, where there is lots of, especially the rail tunnel related tubes that are older than some of them older than 100 years. Yeah, more than 50% of the building stock in Germany has been built 100 years ago, and so they are really a problem in terms of renovation and refurbishment and retrofitting. But also metro tunnels and road tunnels are becoming more and more of a problem age-wise. You have to consider that, for example, in Berlin, in the German capital, more than 80% of the metro system was put into operation more than 100 years ago. And so you can see that all the degeneration that takes place over the years has taken its toll on these tunnels. So the problem here that you often see is that you have the masonry tunnels, especially with these old rail tunnels, and this masonry is saturated with water because often these old tunnels did not have a sealing, a proper sealing that was built into the lining. Then in the, let's say in the 70s, 80s, there were some refurbishment works done using shotcrete layers as a retrofitting measure, but also the shotcrete has deteriorated. These are pictures from a German tunnel called Rudersdorfer Tunnel. It's one of the most frequented cargo lines in Germany, and as you can imagine, the Deutsche Bahn is not really possible for Deutsche Bahn. It's not really possible to shut down these tunnels. They have to find ways to retrofit them and to put them into place with a proper design. I'm going to go over this picture since Roland has already shown that, and I want to show you something like this. What we also have right nowadays is we have huge problems with chloride migration, especially in the Alp region where you have snow in the winter. I know from different tunnels in Germany that have been put into operation, let's say 10 to 15 years ago, and the operators are already contemplating to tear down the inner lining since they have the chloride migration has been such a devastating impact, has had such a devastating impact on these inner linings. So what we are having here is a research project that is funded by the German Federal Ministry for Education and Research. What we want to do is we want to develop a new material with a special resistance against chloride, sulfate, heat, and frost. We want to investigate maintenance of the network availability during the repair so that we can apply this measure under running traffic, so to say. And we want to do risk management and determination of the potential extent of damage during construction. These are the partners that are involved in the research project. On the left-hand side, you see the full partners that are involved in the research and development works. That's us as the TLB, that's Stufa, that's POR, a construction company, and also MC Bauchemie, which is a German supplier for construction chemistry. And also we have some so-called associated partners. This is, for once, the BAST, the German Federal Highway Research Institute. Then we have the Eisenbahn-Bundesamt, which is a overruling agency from the German Ministry of Traffic. Also Hamburger Hochbahn, which is the operator of the Hamburg metro system, and DB Netz AG, which is responsible for the network, for the rail network in Germany. So let's go to the geopolymers and the recipe development. Geopolymers are the expression of geopolymer is sometimes a little bit misleading, because you are tending to assume that this is about something, let's say, very natural. In the end, it's a reaction of alumini silicates within an alkaline media. And it creates non-organic polymers within the structure. So we are substituting the cement as a binder with these geopolymers. The alkaline excitation via matched activators is one of the main parts. And the thing here is that all the cementitious chemicals that you are using on the construction sites normally have to be in exchange, because they all rely on the fact that you are using cement and you don't have cement here. So retarders, fluid ingredients, and so on, they have to be exchanged, and you have to find something different for that. We did prior investigations with our geopolymer concrete. What you see on the left-hand side is a glowing steel block with a temperature of above 1200 degrees, and below that there is a slab, and the slab is covered with it's a concrete slab, and the slab is covered with two different in two tests with two different mortars. On the upper right-hand side, you see a cementitious mortar that is developed for retrofitting tunnels. It has been approved with the RWS curve. And on the lower side, you see our KOINOR system. So you see that even the RWS certified mortar here is totally destroyed by the impact of the glowing steel block. On the right-hand side down, you see the KOINOR system. You see some cracks, but these cracks, they came from the concrete slab below that was deteriorated by the heat transfer, and so the cracks moved onto traveling onto the surface. And we have been doing recent tests with other covers, and there were no cracks at all. So what we see here is no spalling. We don't have spalling with this type of concrete cover. The development of the recipe consists of these binders that you see here. Main part are activators, microsilica, different kinds of sand. It's a little bit of a confidential thing here, because MC Bauchemie, who owns the rights to this, doesn't want to publish these results before the research project is ended. So please take that away from here, that we have a recipe in place that really works. So the current status of the investigation. We started with the application of different temperature time curves that you see on the left-hand side. The blue curve represents the German EBA curve, which has to be applied for German rail tunnels. The green curve up above is the curve for the RWS application. And the red curve was the curve that we used for our oven. So on the upper right-hand side, you see these little specimen that we tested, and we selected. So we made a comparing tests to find the optimum for a temperature exposure, and from there we'll select the recipe that we took for the further investigation. We also make tests to the mechanical properties before the temperature exposure and also afterwards, and which is typical for concrete. You see that after temperature exposure, you have a reduction of the initial value for the compressive strength, which is typical for these types of exposure, and which also can be seen with our KOINOR material. What we are doing right now at the moment is we are developing either a dry spraying and also wet spraying recipe, so that you can apply small margins of the concrete, but as well have a huge application, let's say a bigger tunnel lining, where you have to retrofit more than one block at a time. And the workability of the recipe is really good from our standpoint. We are capable of spraying this stuff already on a regular basis, and we are using the same technique that you would use for let's say normal shotcrete with a cementitious binder. And so we are using the same machines either for wet spraying than for dry spraying. Post-treatment of these geopolymers is a little bit different to what you are than what you know from normal in quotes from normal concrete. We have developed different approaches for the post-treatment system. And we are still checking out the durability of these geopolymer covers with these different post-treatment systems. And I think that we are going to be able to publish results regarding that by the middle of upcoming year. So what we also wanted to do is we wanted to modify the recipe so that we can reach better values in terms of heat transmission through the surface. The thing is, if you consider tunnels in Germany, for example, in Germany we have to have a 6 centimeter concrete cover above the reinforcement by law. That's part of the ZTV Inc., the German regulation. Most of the old tunnels have been built with a cover that is smaller than these 6 centimeters. But you cannot add really 6 centimeters in some cases, since then you would reduce the opening of the tunnel and would not be able to mount ventilators, for example, into it. So what we are trying to achieve is that we also can reach the same level of reduced heat transfer with a smaller cover than we have with a cover of 6 centimeters, for example. We also made some shear tests to find out about the shear, the capability of the concrete for shear to be applied here, so that we can see how the abrasive forces would drag away the cover. And also here the results are really promising, that we can apply the shotcrete cover without any additional measures. Now you see that here we tested that with a typical masonry structure. We also had cast in place concrete foundation, so to say, slabs where we applied our shotcrete, our geopolymer shotcrete, and also a basis of a shotcrete where we applied it on. And the tests were similar good with masonry structures than with cast in place concrete structures. We also try to find out how fibers can be applied to these types of concretes, and the results are rather good. Interesting enough, we have a better with these geopolymer concretes. We have a better capability of adding fibers to the concrete than we have with normal concrete. Since my time is running away a little bit, I'm trying to bring you to the final slides with further approaches. What we are doing at the moment is that we are doing simultaneous fire tests. We have a huge new oven here in Bochum, where we can make huge fire tests with real-time slabs. Also, we can apply to these slabs, we can apply forces, normal forces that would look like this. You have to envision an existing inner lining where you have loading conditions of the inner lining as it is within a tunnel. And then we apply the geopolymer up front on the surface, and we also bring a thermal impact to it so that we can see how this combination of these three are working together. And with this last slide, I would like to Oh, this is this is has jumped into the presentation. And with my last slide here, I would like to thank you for your attention, and I'm open for questions. As I said in the beginning, we have to develop, or we had to develop, a completely new chemistry for additives here. Right now, we can reach an opening time of the fresh mortar of up to 2 hours. That's possible at the moment. No. Bye bye.